Hello everybody, welcome back to my YouTube channel Data Science Galaxy. In this video, I'm going to build exactly two models and I'm going to ask you a pertinent question for you to be able to think deeper to answer. You know what? I'm going to leave you with a very big hint. So please stay tuned till the end of the video and it will be exciting from the learning standpoint. Let's deep dive into the demo. Let's get started with the hands-on demo. Before getting into the building of models, let me just familiarize you with the context and therefore expose you to the data set that you see on the screen. I have a very simple, straightforward, plain vanilla data set comprising two variables, price and square feet. You would know by convention we typically use price as dependent variable, square feet as our independent variable. So I'm going to build two models that I alluded to in the video. I'm going to make use of analysis toolpack in Excel for building the two models. I presume you're familiar with the analysis toolpack that gets baked into the MS Office suite and by default is not enabled. You have to go ahead and enable it. So I've already done that. So I'm going to Data tab and you can see the Data Analysis option here for the menu. I click that and under Analysis Tools, Regression is selected. I shall simply click OK. Once I do that, I'll get a placeholder to key in multiple things. I can key in the input Y range, input X range, and then there are some checkboxes, radio buttons. There are many things happening. I keep it very simple and straightforward. Let's go with the input Y range. That is nothing but my dependent variable, including the values that I'm going to select. And my input X range is square feet label and the associated observations. Notice, while selecting the range, I've selected both the labels along with the observations. So I'm going to simply check this checkbox called labels and leave everything with the default setting here and simply click OK. I think the visibility is less on the other side. I'm going to zoom it a bit to make it quite visible. Let us rename this to be Model 1. You know what? All the three tables here, regression statistics, ANOVA table, and the coefficients table in a regression setting is important. But the motivation is not to look at these two tables, ANOVA and the coefficient tables, but spend significant time on the regression statistics table, even more particularly on the R squared. R squared value lies between 0 and 1. If you have to convert this into percentage terms for easier interpretation, I can do this by multiplying R squared value with 100 and therefore I get 56.74% of the variation. Notice here we have both the intercept and the independent variable coefficients in my model 1. So conventionally, how do you interpret this R squared? Mind you, I'm not talking about adjusted R squared. I'm limiting myself to talking about the R squared. The motivation is to talk a lot about R squared and to nail down certain myths that are floating around in the public domain. So how do you conventionally interpret this? You interpret it like this: 56.744% of the variation in prices is explained by square feet variable alone. Generally, in a multiple linear regression setting, we will say keeping all other variables constant, since it's a simple linear regression where we have one y and one x, there is nothing else to maintain or control. So let me go over one more time. Of the total variability of the prices, 56.744% of the variation is being explained by square feet variable alone, and that's a lonely variable anyways. Okay, so make a note of this point of 56.744. Let's just highlight this and keep it. Let us just highlight this. Let's go back one more time to my data tab to build model number 2. I go to data analysis. I go and select regression one more time and say, okay, this is all pre-populated because for model 1, we have already done this. You know what? Constant is 0. I'm going to check this checkbox and simply click OK. So one more time, zoom it a bit for better clarity on the other side. Let's call this as model 2. So we'll stick to the regression statistics table, particularly to R squared. And before we talk, let us convert it into percentage terms for easier interpretation. So as always, remember R squared would be between 0 and 1. Closer to 1 is the better. We have achieved that goal, isn't it? R squared is approaching 92. How did it do this? Think about it. Look at in the first model, where we have both the intercept and the square feet, we have only 56.74% or 0.56744 is the R square for model 1. Model 2, voila, R square dramatically jumped to 92.482% or 0.92482. What did I do to get there? I just made my friends intercept 0. You know what? R square has the tendency to go up when you go and add variables to the model mix, and fast approaches 1 if you add more variables, independent of whether the variable is statistically significant or not. Unlike the adjusted R square, where adjusted R square penalizes your model for adding insignificant variables, let's just say. But we are talking about only R squared to bust some myths. On the contrary, I have removed the coefficient from the model. After all, intercept is also one of the coefficients in a regression setting. Instead of adding variables to create additional coefficients in the model, I have removed the coefficient. Voila, I've got 92.482% of variation being explained by square feet variable alone for the prices and the variability or the variation in prices. I'm interchangeably using the terms variability and variation. There is a subtle difference between the two, but in a limited sense, I'm using it interchangeably. You know what? This is interesting to say the least, isn't it, friends? Model 1 with both intercept and variable has 56.74% as the R square. Model 2 with only the square feet variable and no intercept has dramatically approached to 1. What's going on? The phenomenon here is very intriguing to say the least. Can I just explain what just happened between the two models with the intercept and in the second model without the intercept? Okay, the puzzle lies in understanding this for a true realistic interpretation of R squared. I want you to give it a deeper thought and spend time examining yourself what's going on. Hopefully, that will reveal a lot of the answers. And in the bargain, you know what? You get to learn real things that matter in a real world setting. As I mentioned at the beginning of this video, that I'm going to reveal hint, here is the time to reveal that. You know what? You have to go beyond the classic textbook definition of what R squared is and what is the interpretation of R squared. And I would also add a bonus hint. Go beyond conventional wisdom wherever possible. I want to hear from each and every one of you. What do you think the phenomenon that happened in the demo that I showed you? And I want you to be describing the phenomenon to make sure you have a solid foundation and understanding of what R squared really is. Friends, here is additional information that I want to share. I'm going to come up with next video where I'm going to do it again in a hands-on mode, exactly talk about what is R squared in the realistic sense of the term. If you're excited for this, make sure to subscribe to my channel if not already. Give this video a like, upvote it, share and subscribe. Thanks for watching. This is Manjunath signing off. Bye-bye. Take care.